just as we were warming up, our main 8-meter dish is out of action, following the clunk that we showed you last time. So they've dismantled the worm gear and hopefully secured the dish so it doesn't fall over while it's not got the worm gear in. But they're going to replace it with something different, and that's going to involve cutting out a big chunk of the steel framing. It's going to cost a large amount of money. We were just going through it the other night in our meeting on Monday. But the president of the Astronomical Society was present at the meeting, and he didn't seem to have a problem finding the money. So things are turning, wheels are turning. But so what we're doing at the moment is using the grid mesh dish that I've got along the lines of Alex's scope in a box, and the foil horn. And we were to have had a public event. When was it last? Not this weekend, the one before, a week ago. And we were all set to go up there. It's about a 2-hour drive. And it was then declared a day of total fire ban. And as soon as the total fire ban is declared, that's it. No one goes anywhere near. We're not allowed on the premises. So there were 200 people all set to go up to the dark sky site. And it was cancelled at 2 o'clock on the Friday. And people were going to go up on the Saturday. I was about to leave work and jump in the car and head straight up there for Friday night. And luckily, I checked my email, and yep, total fire ban. So that was the end of that. So they're rescheduling for something like May the 13th, I think it is. So there'll be more to report once we've had that. That's a public event. It starts about midday. We do solar stuff during the daylight hours, plus our radio astronomy. And then there's the local Lions Club does a barbecue for dinner, and then the telescopes are all set up by then. And then people stay as long as they want into the evening, depending on the weather and the cloud cover and so on. So coming out of that, that's a long story to introduce what I want to ask, and that is, we want to put up a panel or something like that, so that when members of the public come by and see the grid mesh dish and see what we're doing, they've got some sort of written or graphical explanation of what it is that we're doing. And I think it was Roger, were you talking about that just at the beginning there? Or was it Roger, or not quite sure who was talking early on, trying to get some explanatory materials together? And so I wondered, Rich and Alex, whether there is something existing already that gives some background and some explanation about how scope in a box works. So the idea of collecting across an area, the idea of what the feed is doing, amplification, filtering, and then processing. Are there some materials around already that we can draw on rather than reinventing the wheel with this? So that's my first question for the day. Rich, I don't know whether that makes sense, but perhaps we can.
Oh, it does, and I think Alex's video is a good start of that. But he's more in. I think I was more into the build of the feed. We got YouTube, or a lot of YouTube data on people trying to use it, and we've got journal articles, a lot of journal articles on it. It's just a question of pulling all those together. I'm not sure we have a video that sort of walks you through everything. What do you think, Alex? Do you know of something that, would you recommend something right now?
I mean, there is tons of stuff out there. Even Wolfgang's introduction that was done the same time I did did my video has good information. I mean, I don't know there's something precisely tailored to what you want, Paul, but there's a lot of information out there. I mean, you can even go to the what is it? Hold on, let me see, what's this site called? RTL.SDR.com. And I mean, there's a bunch of videos on there about, yeah, RTL.SDR.com is a website that has some basic stuff. Hold on. Wow, that's a long. Just do RTL-SDR.com. And it gives you information about the scope of the Vox level system.
Yeah, we're trying to get something that's static. And videos are good. You can put a video on a loop, for example. But something static, I don't know whether that's going to show. Let's turn the blur off.
Yeah.
The blur makes it. Then you can see all the mess behind me. But really talking about something like would be a poster or a panel, one of these freestanding panels. And my idea so far is to talk about astronomy in general, so optical astronomy. There's my finger here, and then some of the satellites that are looking at different frequencies, and then so we're talking about the nature of the signal that we're receiving. And obviously there's a whole range there. But if we concentrate on the hydrogen line, where it comes from, the fact that it's weak, so how do we address a weak signal? And there are a number of ways of doing it. There's the large surface area, VLA, those sorts of things. So lots of dishes to increase the area. Or then in our case, small area, relatively small area, but lots of amplification, and then filtering so that we only get the bit we want, perhaps more amplification, and then time averaging, which is the way that we make it work, obviously. If you average over 5 minutes or more, and then cancelling out the noise to some degree, you get a better signal to noise. So we have to try and explain that to someone. Oh, and then the processing, what are we actually getting? Eventually we just get numbers. And can we turn the numbers into a graph? And can we turn the numbers into some sort of map, some mapping? That's really sort of, it has to be summarized at sort of the level of a total novice walking up and wanting to know what's going on. And at the end of it, they go, oh yeah, I can see what you're trying to do. That's where we're trying to get to.
Well, there was a printed journal that had like all my PowerPoint slides on and many others that was published a month or so prior to last summer's conference that has printable material.
Do you know which one? Let's see. That'd be you at the Eastern Conference. So that'd be the July.
August.
Yeah, the July-August 2021, 2022 journal.
Yeah,
somewhere in there.
Yeah, it sounds like digging back through the archive of journals would be a good starting point.
Well, if you go to the SARA website, and there's an index of journals which will let you download the Excel file that you can do a search on, and it'll tell you which journals based on which topics and and who the you can look up Alex directly and find all Alex's articles and stuff like that.
Yeah,
that's probably a good start for the journal stuff, and it'll also give the links to the YouTube channels. And I'm almost ready to update that here based on the last set of stuff we just did.
Yeah, I quite like the idea of a video. Just a video running on a loop is quite good. And it takes something that would go for about 3 or 4 minutes. round and round. So because that's all that people won't hang around for a longer video on a day, on a public day. They want a quick grab about what it's about, and then they might have a few questions, and then they move on to something else.
Can you take a fraction of Ed's introduction video that's up on the Sarah TV or YouTube channel?
Yeah, I think that'll be the key to do a bit of editing. Just to take a chunk.
Yeah, that and Wolfgang's and Ed Harfman's videos are really our key introduction.
Yep.
And what I find when I give briefs to people, you know, us engineers, you know, we just love filters and we love processing and all that kind of stuff. What most people don't know is, well, what the heck are you looking at, and why do I care? And how you do it, the fact you got a big dish is cool, and the fact that all that stuff's turning into some kind of a picture of, you know, of hydrogen, which they don't understand. You know, so what? You got a nice blip there. That's, you know, if you get them that far where they understand that you're actually receiving something from space and you got some kind of a signal, that's about as far as you're going to get. So the detail of where the filters are and, you know, even the schematic is almost too much from the start. So I think, yeah, the Wolfgang who basically shows, here's the basic system, and here's here's what we're looking at, and then all the way from pulsars to, you know, he does all that stuff, and then Ed's stuff, which the basic science stuff would be great.
Yeah, I was thinking also with the radio eyes software, there's that nice graphic of the Milky Way, showing you where the hot spots are and so on through radio eyes. Trouble is, it's presented in right ascension declination, so you don't actually see the true shape of the Milky Way.
Well, what I like is Alex's picture of when we do a drift scan through the Milky Way, and he's got the stellarium, and he shows where the drift scan goes, and that shows you what his picture looks like. I think that is neat. And I'll you send that to him, Alex. But that's a sort of a neat picture of, you know, why does this signal look like this? It's because here's the way the drift scan works, and it's actually moving up the Milky Way at the end, which causes a funny signal there.
When do you want to put that together, Paul?
Well, as I think I think our next public session is sometime in May. I'm just having a look through my.
I hopefully get a couple other at lower declination. So hopefully I'll have a few more by then.
Yeah, May 13th is the next public. I like the idea of something on a screen that's actually dynamic, because that it saves you having to explain it in text or in diagrams. You can do some explanatory stuff alongside a video, but certainly the drift scan where you actually see is it a 24-hour or a 12-hour or whatever, and you see the signal varying. I think even the idea of signals from space, I think is new to a lot of people. I mean, radio astronomy would be a complete unknown, because a lot of the people that join the ASV do so for optical astronomy. So they know about telescopes and binoculars and astrophotography and so on, but they don't know much about radio astronomy. I think, Roger, you're in the same situation in your group there.
Yeah, absolutely. Which I'm pretty happy to be with them in their optical observing, but yeah, they don't know much about the radio side of it. Although we do have a reasonable number of, you know, technically minded people amongst it, but yeah, an awful lot that aren't as well.
Yeah, I suppose I'm really talking about the public, when you have a public day.
Definitely. Yeah.
You're talking people who, you know, show them a telescope, they know exactly what you're talking about. Show them a dish, and they no, this is all new territory.
Yeah.
So I guess sorry.
Oh, sorry, I think I've said before, we have a contemporary arts festival near us at the moment. I'm gearing up to try and get something to working with them when we're dealing with people there that hardly know what radio is, let alone radio astronomy. I'm trying to do the sonification part to do an audio just so they can see what's happening. You know, point a dish in the sky and there's something coming that they just can't imagine, really.
Yes. Yeah. So I think Rich, probably it's if you step back one step, it's really about that public outreach stuff and sort of an introduction. What is radio astronomy? We're almost back to that, and the fact that you can do this on a little 1 meter dish that you can pick up and just point at the sky, even getting that message across, I think would be significant.
Well, I sort of found when I was first starting out, and I'm very highly technical, I thought, is getting the Super SID and the Radio Jove was the key, because I could see solar flares real easy with the Super SID, and the fact that I can actually see and hear things from the Radio Jove was and people can understand that. When you start getting to the hydrogen clouds and the Milky Way and pulsars and masers and stuff like that, that's almost beyond the astronomy of most people at the beginning. They understand the sun and they understand Jupiter. So that gets them in, and it's really cheap equipment to go buy and install, and they don't need a dish. And then when we start putting the scope in the box system together, that sort of drew the mid-range people into hydrogen, and they were very good at that. And then the high-end people with dishes are doing pulsars. And then we got a bunch of 1 meter and 2 meter, 3 meter people doing the masers now. So I'm sorry, that's my daughter's dog. Anyway, so I think that's sort of the progression is you get them sort of hooked onto the of detecting radio signals up front on solar flares and Jupiter, and then that's that gets them into you can start doing hydrogen and dishes then.
At the next stage, I think we do have an Eclipse. We've got a log periodic that tracks across. It's not continuous. It jumps. That sort of does as the day goes by. And we've also got a Radio Jove, the parallel dipoles sitting there. So we've got and Super SID. We keep saying, well, we must put an order in and get a Super SID shipped over, but time seems to keep slipping away. But we've got a loop. Actually, we've got a loop antenna which we had specially made for the Super SID stuff. So we're well set once we get it all set up. And I think you're right. The key is to get across the idea that there are radio signals coming from space. So it's instead of light, it's light in optical, visible light. It's in some other part of the spectrum, and some of it's coming from the sun.
The other thing that you could probably do is the meteor reflection stuff. There's a lot of people who have that online. One of ours, Chip Safici, has his own website where you can basically watch real time meteors coming in from the reflected signals, and that whole bistatic approach was people transmitting and we're receiving is pretty good. And you guys got an eclipse coming up?
Yes, in Western Australia. So a long way from here. But,
because I was able to detect an eclipse with the Super SID. And it looks like it almost looked like a solar flare, but so that's something you can have a campaign for and see if people can detect that.
Yeah.
Um,
I think we in
amazing.
Melbourne, I think we're going to get a partial eclipse. Memory. Ooh, it's right over in
It's
the
mainly over the ocean here. I'm actually booked in on a cruise that leaves Fremantle that's going to go and chase it, but it just touches the very western peninsula in Australia. That's the only landfall. The rest of it is over the ocean, except for in Indonesia. It goes over Indonesia as well.
Yeah.
But it's actually a what's the word? Well, it's a
hybrid.
A hybrid, that's the word. Yeah, it goes from a partial eclipse to a full eclipse, then back to a partial eclipse again.
Yep.
So I'm hoping my captain on the boat that I'm on is going to go to the best spot with no clouds, but we'll wait and see until next month.
Yeah.
well, you don't have to be in the eclipse area to see the eclipse with the superset. It just has to be between the transmitting station and you, the eclipse happens. So if you can find sort of that geometry where the eclipse is crossing, find out where the transmitters are, and then your superset has to be on the other side of the eclipse from the transmitter. And then you might be able to see it. But you don't have to be in the eclipse. In fact, it's good not to be in the eclipse with your superset because you want to be on the other side.
The closest one for us is actually right where the eclipse is going to be, ironically. That's the Harold Holt in Western Australia, right up on the peninsula there, and that's actually where just about you'd be able to see the eclipse, Roger, I think, from Harold Holt.
Yeah, I think that's the American spy station. Is that how we put it politely?
Yeah, you could say.
I think it's actually a submarine.
Yeah, submarines. It's called
transmits to submarines.
Harold Holt was a prime minister, and he's in fact the prime minister who disappeared. He went swimming, never came back. So it's got another name, Roger. I can't remember, or Rob might know. The
Exmouth Peninsula, I know that, but I don't know the name of the transmitter.
You can see it on the if you get on Google Maps or Google Earth, you can see the massive array from above. You can see all the antennas and so on. See if I can find it and share it.
So Paul, my last recommendation, I'm going to shut up here, but we do give grants out, and we give grants for supersids and Radio Joes and even the scope of the box. All right.
Yep.
So if you guys want to have, one of your schools apply for a grant, you can get a couple supersids out of it, a couple of Radio Joes out of it, and then you can help them set it up. And we end up paying for the equipment.
Yep.
So all you have to do is just let me know, and I'll hook you up with the grant coordinator, and we'll get you signed up. Right now, we've got all our grants are going to India. I mean, it just seems that they love this stuff, and so we've got about 5 grants already in India. So I'm pretty sure that if we get to India, we can get to Australia. So.
Yeah. Well, I certainly had that in mind, and it's just a question of me getting around to filling some forms in, I think, Rich. But it's very generous from Sarah to be able to do that. So there's the what do they call it? The Victorian Space Science Centre. Emma Barnett was with us last time, and they're keen to do some of these things as well. But I'd certainly like to set up the meteor tracking. That's just a simple antenna and a receiver. We can set that up as a portable, even ready for the one in May. Then the supersid, that would be a real winner. I'm not sure where other transmitters are. I suspect that the signal strength from the Western Australian one is probably so strong. I don't know whether it's going to show variation. It's a really strong signal where we are, even over here. Can you receive that, Roger, or Rob? Do you pick it up?
I haven't even tried.
No, I haven't tried, but it would be a good bounce off of meteors from here across the country. It's worth thinking about. Rod, so what sort of frequency or wavelength do they work on?
50 megahertz. Used to
Yeah,
be the
50.
analog TV station. And Ted, what do you think that? I mean, you're a Meteor guy. You've got that thing set up at the little Thompson. What is it currently now?
You look for meteor showers, of course,
Yep.
but I'm thinking that the best time to receive it is from midnight to noon, and
Yeah.
either be in the afternoon when there's kind of a lull of meteors,
Yep.
so you don't have anything to show. All you see is static. I'm
That's-
thinking that we're talking about radio astronomy. Astronomy means looking up at the stars, and you're just doing it with radio, and that's what I would emphasize. And so
Yep.
you talk about that you point up in the sky, and if you stay there, this Milky Way comes by twice a day and gives you blips. And then you can show pretty pictures, and that's about where the conversation ends, and that's good
Yep.
enough.
Yeah, I think that's right. I've got a little VLF. That's a, what do you call it? Converts the frequency up to 10 megs, and that gets me the Western Australian VLF. It's on about 19 kilohertz, 19.8 kilohertz, I think it is. But
If you just showed that the Milky Way came by and went blip, and here's another blip, and you
Yep.
see one is bigger than the other, you've kind of started talking how you can paint the sky, and that
Yes.
that seems closer to the astronomy that everyone's familiar with.
Yep. I think that's right, Ted. Yep. And get into the technical stuff. If people want to hang around a bit longer, they can get more technical. That's the one that I think can really be helpful. Showing-
Yeah, but it's got the wiggly part. It's
yeah,
Milky
that's
Way
right.
is at a different plane than the equator, and
Yep.
that hurts your head. After practice, it gets better, but
So
that's too much education.
There are
but if
some
you get
with it.
but if you get somehow that it comes by and goes blip blip twice a
Yep.
day, that makes sense. And then cool, there's something invisible you could see with radio.
Yep.
And
Well,
it's a big dish, boy, that could be great. How do I show up?
Ted, I'm gonna disagree with you a little bit, depending on the audience. We like blips because we're engineers, but people don't understand blips. They think that, well, that's nice, I can get that on my TV. But that picture, the colored picture, is you turning those blips into that colored picture. Even that, plus the one you just had with the radio eyes. So that's something that understand that the Milky Way is going by and I'm detecting it. All the red stuff is what those blips mean. And I think that's the transition between, a double E perspective and a novice radio guy who just wants to do some astronomy, that doesn't have the technical background to understand how the blips convert to that. Stuff like that.
Yeah.
I mean, that's what I'm thinking. I'm
Well, if you
just
find
doing
the
this 'cause
linear version, find
Yeah.
the linear one that shows the Milky Way but shows it as a straight line. People would understand it probably better than that curly one.
Yeah.
Yeah.
Now this one here, you can explain how we got these big white spots where the southern hemisphere is, where we don't have any data, and you guys can explain that how you guys are going to fill that in, help us fill it in, and we're going to help you fill in right there. That's all. That's from Roger. You need to fill that in with your one of your telescopes, that white spot there. And
I'm onto it.
Yeah. Well, once ours is fixed up, we can fill in some gaps. But
I
I think
thought it'd be so much fun to show data that you actually created, and
Yes.
so I'm not trying to push too hard.
No.
It takes a long time to get all the other drift scans to make the
Exactly.
pretty pictures.
Yeah.
Good luck. Let us know if we can help.
Yeah, I think it's the entry level, the Joe Blow who turns up on the day, who knows about telescopes and optical astronomy, and then you really just, it's a toe in the water. You can get other radiation from space, but you have to do different things with it. And if they go away with that message, then you've won. But then when we have members only nights, I think that's where you can go to the next level and build up there. The members knowledge, because they're already immersed in the astronomy itself, and we can go up to the next level. So, yeah, good conversation to sort of try and pin down exactly what we need to do.
Well, the one other factoid here is that we had a high school student who wanted to do some radio astronomy, and all I did was give him the data from my drift scans, showed him how to sort of plot it, and then he went to state, because it is such a the science people, it's such a new concept to a lot of the science stuff that people think it's magical, and this high school student caught on extremely fast, and we explaining it to him, he just went all the way to state because people were amazed that this was happening. And so it's definitely, the high schools are figured out faster than us old guys.
Yep.
We just need to give them some tools and some data.
Yep. There's a foil board dish or a horn.
Yeah, Ted's got all the
We've got
tools.
all the gear. We just need to put some words in front of people to explain what the stuff is doing. So we've got a horn as well. We take the portable ones, but we've got a fixed horn. Well, no, a permanently mounted horn that we can swivel, and that's back in action as well, I believe. All right, I think that's given me enough to go on there. Rich, shall I keep going with the other one? The STEMsat. I want to hear a bit more about STEMsat, which I think Sarah driving that.
Sarah gave a grant to the Athens State team that's doing that under Dr. Wayne McCain. And if you look at the YouTube videos for the Western Conference, there's 4 of them that deal directly in that. And I think one of the particular ones was from Mel, I forget his last name, who gave, what are we actually seeing? What are we trying to see with this CubeSat that's going to be in low Earth orbit? That's science. I think that they're going to start looking at 20.1 kilohertz, which is right around where the SuperSID works.
Yep.
But they're going to look above the ionosphere where most of that radiation bounces from the transmitters. And what can we see then? So anyway, it's fun. It's teaching everybody the space science and the astronomy, everything at the same time, and they get to build some hardware. So it's going to be a great project. So
the question was, from this end, is it a US only project or is it a worldwide project?
Absolutely not. Wayne would, anybody who wants to play, Wayne will jump in and give you a job. He was looking for collaborators. I think the thing that would help him, which you guys can definitely do, is put up a AMSAT ground station so that you can listen for the satellite going over when it goes over the Southern Hemisphere, because we don't have any. There's no Southern Hemisphere AMSAT ground stations, and you guys would be perfect for that. And then you can transmit the data. It's receive only, so that they're not transmitting up to it. They're just receiving the data. And I think the limited storage in the spacecraft, the little CubeSat, says that the more times that people can download the data, the less they're going to lose overall. So I think if you guys worked with him and put up an AMSAT ground station, it's just one frequency down. And I think it's in the, look in the ground station YouTube video on the Western Conference. And if you want to contact him, he's absolutely will jump in. He's looking for collaborators, and you guys are perfect. And you can use all the data.
Wayne, was it?
Yeah, what's his
Dr.
name
Wayne
again?
McCain.
Sorry?
Yeah.
Say again?
Well, I think Roger was looking for the name. Dr. Wayne McCain from Athens State.
Okay.
If you look at the YouTube videos, it actually has his email there. Use my name in vain. Said, I told you to contact him, and yeah.
And
And if you guys,
we
you wanna
certainly
get
have
involved?
people in Australia. I know there's one in South Australia who have the tracking ground stations. They just put in the elements and off it goes.
Perfect.
So we could piggyback on some of the existing gear, but we'll also get schools involved.
They'd
Because
love it.
just a handheld 70 centimeter antenna is going to get you there. It's a bit like FunCube. Some years ago, we were involved with FunCube, and that was, you grabbed the data straight from the satellite, and then it processed it and sent it off over the internet in real time into the repository. I think we were the first school to send it in from Australia.
And I think this is one of the first amateur radio astronomy CubeSats.
Yep.
So you're actually getting data, radio astronomy data, real time.
Yep.
Just so.
I think they were hoping they might even get some some Jupiter emissions when it's in the dark.
Well, I was going to ask Richard about that. 20.1 megahertz, kilohertz
21
is
point kilohertz.
is this CubeSat they're going to put up there, and they were wondering if Jupiter, if they could see anything from Jupiter with that CubeSat.
Hey, Rich, I honestly don't know how to answer that question. I doubt it very seriously. I don't know what kind of antenna aperture they have, for those frequencies.
It's a dipole about that big.
It's very small.
But it's above the atmosphere. So
it's in the clear.
Unfortunately, most of my familiarity with Jupiter is in the decameter band and not the not the very, very low frequencies like that. So, but my guess is no.
I did wonder about that, Rich, whether, were they confusing 21 megahertz with 20 megahertz with 20 kilohertz?
I wondered the same thing.
When they said 20.1, I immediately went to megahertz.
Yeah,
so
but it's kilohertz. And so they're more into the super SID range than they are the VLF range than the Jupiter stuff. So. But look at Mel's brief on the YouTube channel, and he brings up Jupiter. I think he's a little bit of guessing that maybe he gets some from Jupiter, but I haven't seen anything at that range from Jupiter outputs yet.
But we just wouldn't know because the atmosphere is in the way. They're up there above the clouds,
that's their key.
And we can't see as well as they can. So this is the thrill of the adventure.
New science. That's why we need to get the Jupiter guys there to look at the data to see if we find new science.
So that everyone can put up a little stem sats. Yeah, that's right.
That's right.
Do measurements.
I have a question about that frequency.
Yep.
That's right in the switching frequency of millions of all kinds of switching power supplies. Being above the Earth, wouldn't you even be more exposed to all this RFI hash?
Well, wouldn't it bounce off the ionosphere back to Earth before it goes out?
I don't know.
I don't know. I mean, that's the question I was posing.
As Ted says, it's new science. We don't know yet. Right. I mean, the thing with Jupiter is you'd have to have the satellite in the shadow of the Earth, so it's not picking up the sun.
Right.
Then you got to have Jupiter on that side, which is what? That opposition, or I can never remember which way around it is. You've got to have Jupiter over that way. So there'd only be certain times of the year when it would work, depending on the relative orbits. So I don't know how long this thing's going to go up for. How long will it last up there?
I think 6 months to a year. I think it's going to be a little higher than they thought it would be. And you're right. I think the concern these guys are having is that there's going to be so much data to plow through and so much, RFI to negate that they need help analyzing all this mass amount of data they're going to get. and they want to, they want to see about flares. They want to see about if they can see Jupiter. They want to see what else they can see with that that little CubeSat. But it's going to go through all that data is really the issue. And so you can offer them that too.
It's interesting. It's already grown from 1 unit to 3. It makes you wonder how big it'll be once they launch it. If it keeps growing.
Only so big those little canister things will pop out of CubeSat.
They have to have a slot on the host vehicle.
Right. Well, they already got that. They've already got all that worked out.
They've got 3 units, but so they can't grow anymore.
They can't. They've already got the 3 unit slot, I think. So they're stuck with that.
And the main thing is that the solar panels come out and deploy properly. Otherwise, it's not going to work. Right. Presumably, I assume they're spring loaded in some way, aren't they? Are they sort of held and then they pop out?
It's fully autonomous. So they're not sending up the CubeSats I've worked on before. They'd send up a signal which would burn through a little wire that'd pop everything out, including the dipole. Here it's supposedly just timed. As soon as it releases, there's so much time that it's going to pop. Right. Everything will pop out by itself. And the first time they'll know whether it's actually worked is the first downlink they get. Yeah. And they get to then they'll see if anything worked.
Well, they managed it with James Webb, so we should be able to manage it with 3 units CubeSat.
So when does it launch, Rich? When does it launch?
Early next year.
Yeah, early next year.
It's shifted. It was to be the end of this year, I think. It's got bumped to early next year. So we've got plenty of time to think about it.
Yeah, I think you guys have a blast working with this project. It's the other thing is you might be able to duplicate their design and have your students look at building some of the equipment and learn about launching and how they do telemetry and all that stuff is very fun for the whole space community. Is very fun for high school students now, even if they don't get into radio astronomy, just launching a satellite and operating it.
There's a MSAT has a CubeSat simulation kit that you can get. It's not too bad. Pretty easy to implement.
And we put a helium balloon up in November, December last year, 32 kilometers up. There's no reason why we couldn't send a little CubeSat up with it.
Did it fly over the US and did you lose it?
It flew, ironically, because the students chose which day, because you can go on a website and you can get predictions about if you launch it from here, which way will it go, which way are the prevailing winds. So we drove west of Melbourne. It was about 2.5 hours to get to the launch site, perfect launch site. Up on a low, what they call it, bald hill, exactly what it was. And went up and it fiddled around for a while, went in little circles. Then it went over the Grampians. But the trouble is it went west. And the day they'd chosen, the prevailing winds up there were west. The Grampians are a very big, probably not on your scale, not the Rockies or anything like that, but on an Australian scale where we don't have big mountains, Grampians are pretty big. But it went up to 32 kilometers, drifting west, and then it burst and came down. So we had to drive right around the Grampian ranges, and then we followed it. It was being tracked from my receiver back here in Melbourne. So we were getting a very good signal from it. And then we landed in a field, and we just went in and picked it up and grabbed it. But Ted, you were talking about the ones that go around the world. They're a different exercise altogether. It's a bit like the weather balloons. So it's the same technology as the weather balloons. In fact, the transmitter is the sonde that the meteorological balloons use. But there's no reason why. I don't know what the weight is of these CubeSats. What sort of weight are we talking about?
Couple pounds.
How
Excuse
many?
me. Metric in the imperial terms, it's a couple pounds, which is a
kilo.
Yeah.
Yeah. Okay. Well, yeah, we should be able to get a kilo. We certainly had cameras go up. So yeah, that would be an interesting exercise.
Well, that's something you can offer them, is that they build a prototype, then you can put it up on a balloon and see if they can test everything.
Yeah,
that's a thought.
Yeah, well, we know how to do that now, having learned it last year. And our lab manager was getting all the stuff together, and I said, "Should we do another one in 23?" And he said, "No, it was too much hard work."
But you'd have a prototype CubeSat to test out for them.
Yep.
If you can launch it.
Yep. That'd be worth pursuing, I think.
All right.
All right. That's all from me, Rich. If you want to pass on to next people.
Oh, okay. Let's see. Let's see who's on. Ted, what do you got going on, Little Thompson?
Well, you've inspired us. We're going to go try looking at pulsars again. I was going to think, well, we might just start playing with the old data I did about 2 years ago and see if with new techniques we can pull a pulsar out of it. But otherwise, we moved that dish with the red stick behind my ear here, and it worked again. So that's good. After several months, it lives again. Otherwise, I'm playing with software and doing all that kind of stuff. Let me know if I can help, folks.
So what he's talking about is the dishes he's got there. They're the guy that does our pulsars at Deep Space Exploration Society, which is in Haswell, Colorado, is going to bring his equipment up and plug it into Ted's dish there, and see if they can pull out, which is our brightest pulsar, is VO329 plus 54. So we're going to see if we can get that from the Little Thompson Observatory and get their first pulsar out of it. So, and that's just a question of putting on the back end Ted's 1420 megahertz feed, and see if we can pull a pulsar out of it, because he's got tracking on there. Okay, Alex, what you've been doing a lot of feed work and hydrogen work, which sounds like Paul really they love to have.
I've been trying. Well, I don't know, Paul, if you saw the presentation or the info on the umbrella antenna that I designed, but that might be an interesting hands-on project too. And that brings up an idea for a standard test. Ted showed that horn and the scope in the box, and there are a lot of very beginner antennas, but there's no standardized that thing. There has not been a standard way to compare these. There's the other one. And what I have done, and I had a sample of data from Mike Odie, is to capture some data at the brightest spot in the Milky Way, that's in the Cygnus area, and scale it in decibel scale, the ground level 0 dB being cold sky, and measure the amplitude. And that way you can quantify some of these different designs. You can quantify your own development process, but then you can compare one to the other, because the only data point I have from anyone else was Mike's. And I want to show you something here. Have a new personal best on my scope on the box system. A challenge. Here's the challenge for you, Paul. Hold on a second. Let me see. Share screen. This guy. Share. What I did was I turned my scope in the box system around to the same type of center support that I used on the umbrella. Reason being, the tripod support was very difficult to adjust in small increments. Having just a single center point worked really well. And so what I found was I could tune this spacing to within adjusting this standoff distance a few millimeters at a time to get a really deep notch at 1420. And so this turned out to be 34 millimeters to the back of the choke ring. And here you go, 2.5 dB above noise level. The basic scope in the box comes up right about 1. And about a year ago, I was up just a little bit below 2. So a week ago, I got up to over 2.5. So, and see, this would be a nice way to compare systems. Anyhow, that's all. That's my 2 cents. Oh, this is what Richard was alluding to, but I think this is too busy. This is a drift scan at 60 degrees declination, and what's interesting about that is you never get out of the Milky Way. So one side blurs into the other, but this is a velocity intensity scale. I think this might be challenging to interpret in a few seconds. So probably Ted's pure amplitude scale would be better than this.
I think it would be attractive because of the color and movement. I mean, people would not necessarily understand it, but it's very striking.
Some interesting data, yeah.
Yeah. Where is that image, Alex? Is that?
I don't think. I'm not sure that it exists anywhere. I'll send it to you.
Yeah, that'd be great. Thank you. And I saw something you were writing that the different grid meshes, some are better than others. Is that right? Is there a 17 and a 2.4?
That's not the grid mesh. That's the. Hold on a second. Do I have both of these?
I think it was a Wi-Fi.
It's the Wi-Fi versus the GOES, and
okay, right.
The GOES doesn't work. I thought it would, and it did. 3 years ago, to have a little bit of this above the noise level was success for me. But looking at it again 3 years later, this doesn't work. It is the length of the GOES for some reason is 38 centimeters above the dish, and it's too long. I had to, and the Wi-Fi is 34. I shortened it, and the GOES works. So yeah, the 34, 35 centimeter is correct. And for why they built the 1.7 gigahertz weather satellite feed for 38 centimeters, I don't know, but it doesn't work.
Well, that's what I've got.
Well, you do.
I'm getting a signal.
Let me think where I have the pieces. Hold on a second.
So your territory might be quiet enough that it would work fine. He's just fighting an RF noise floor where he's got to put a filter on the front, and of course that makes it less sensitive.
Well, everybody's bringing their antennas out. Is that, if it's too long, that means they're getting spillover, which is they're seeing the ground noise?
What I've got. This is the 1690. That's the 1690, Alex.
Yes. Okay. And so that's wrong. But it's easy to fix. Okay. This is the way it looks, and all you need to do is to make sure the cable is free, and you can tap on this and you can knock this out. And what it is, it's this deep sleeve that's basically held in with maybe like a little bit of silicone cement, but you can tap it out tap this out and cut 3 centimeters off of this length so it's shorter.
Wow.
Try that.
Mm.
And that will bring it back. Let me show you something else. I don't know if this makes sense or not. This is the base. This is where the 2.4 gig hits the antenna. These for both the 1.7 and 2.4 gig. This piece of aluminum is the same length. So that is what the Wi-Fi dish looks like, and this is what the GOES did. If you forget that little thing, it was made that there was more material on the other side, and I don't know why it's not the focal point of the antenna. The focal dish it's about a 0.35, so it should be 35 centimeters, and for some reason the weather satellite's at 38.
I wonder if they want a broader beam, because the dish, the thing goes over your head and you don't particularly track it. So it might just be, well, of course, why would you have a dish? So yeah, I guess so.
All right. So Alex, is that causing spillover, or just the focal point not enough? It's just not focusing correctly, or?
Repeat the question.
Is having it shorter, one, making it focus, but also preventing spillover of the dish? And you're seeing ground noise? Oh, you're on mute. You're on mute.
Yep.
When I ran tests on the stock weather satellite antenna a couple weeks ago, I got 0.3 dB above cold sky. Mike sent me data from the Wi-Fi, and it was a full dB. I shortened the GOES down, and I got 1 dB. So it's huge. Yeah.
All right.
Alex, could I ask you a question?
Yes, sir.
You were mentioning about a standard way to compare systems, and you didn't mention G over T, where you're looking at the sun and cold sky. Do you have some particular preference for doing it the way you mentioned?
Well, my problem with the sun is that it's so small. It's like the half degree width of the sun versus is like 1/400th of the sky, and so I don't know I don't know if that's a real good number. It's so dependent on the size of the dish.
Yep. Okay. Thanks. It works well for big dishes, I think, but you raise a good point. Yep.
All right. Anything else, Alex? Or okay. Richard, now we got you online. What's going on with the Jupiter community, and or anything else you got going on personally?
Well, I guess most of you are aware that Jove is now Jove 2.0. After getting 2,500 Jove 1 receivers out in the world, we're switched over to SDR plays, and the antenna is still the Jove dual dipole. So the program is moving along. A lot more people are getting spectrograph data. Here in Hawaii, it's been pretty disappointing because we had an observatory over at Windward Community College where we used to fight power line noise a lot, and they took the power lines down, and we thought that's great, and they replaced them with a huge array of solar panels on top of the parking lot right next to our log periodic antenna. So here in Honolulu, the background noise temperature is on the order of 3 million degrees Kelvin. So that makes it really, really tough to do anything here. Jove is looking forward to doing some eclipse work in the near future. The next two eclipses across North America, one this year and one the following year. So things are moving along, and we certainly continue to appreciate the support that Sarah has given, and I guess you guys have sent a few more kits to India. So.
Yeah, they love Super Sids and Radio Joes.
Yep.
What are you observing with Radio Jove for the eclipses?
Usually, the last one we tried, changes in intensity during the eclipse was what was being observed. I don't know. Chuck is in the process of putting together a so-called citizen science plan for what will be observed in the upcoming eclipses. One of the things we've had so much trouble with is finding stations that aren't wiped out with RFI. I mean, it's just getting really, really difficult. Gosh, I remember decades ago when we, particularly in the Southern Hemisphere, we had a station up in the Andes in Chile. And that was phenomenal. I mean, it was so quiet up there. And so we really miss having some good, quiet Southern Hemisphere data. The other thing that makes it difficult is, the real hard Jupiter science. An awful lot has been done. And so it's kind of tough to come up with a new science to do, for people to get engaged in. But the good thing about Jupiter is it's dynamic, both Jupiter and the sun, and it's much easier to catch people's interest. And when they see and hear these bursty radio signals coming from space. And I think there's a lot to be said for doing that in catching the public's interest, is to have a good audio recording, perhaps, of Jupiter that they get a chance to hear. I personally find it a little easier to understand what a parabolic dish does when I look at it and compare it to a telescope than a couple of wires, a couple of dipoles hung out between the trees. So I think there's a lot to be said for engaging the public with Jupiter and the sun, just because it's dynamic and kind of fascinating to listen to. Anyway, that's kind of where things are that I can talk about with the Jupiter program. Personally, I'm building a 1 meter RF ham design dish, and I want to listen to some lunar satellite, lunar space probes. And that's coming along, but it's tough because I live in a small apartment and it's very noisy around here too. So the higher I go in frequency, at least it gets a little less noisy, but it's still tough. So that's it, Rich.
All right. Any questions for Richard Flagg? All right. And he's got a ton of YouTube videos up on our site. That was 2017, I think those videos were made. But okay.
We do have our system up at the Dark Sky site for the Astronomical Society. That's pretty RF quiet. I might make sure we're in working order.
Great. Lucky you've got one of those sites.
Is there a name to it? If you had to go, you got it hooked to the archive. I mean, automatic transmission to the archives. And what's the name? Any idea?
For our system.
Yeah, is it hooked to the internet where they can automatically transmit the data to the?
It's streaming. I'm not sure whether they're streaming to the data to a central database. I'll check.
All right.
And if not, why not?
Yeah, I think they emphasize that you've got a dark side. Dark sky and your southern hemisphere might be. We'll start looking at it longer.
Yeah, putting data into the Jove archive is always certainly appreciated. And you want more information on how to do that, it's on the Jove website.
Yeah, all right, I'll have a look. Richard, it's good to have Richard on board, because your name is synonymous with Radio Jove as far as I'm concerned.
Well, I hope that's good.
Probably offer you, we could probably offer you a site in New South Wales too. We're probably not quite as radio quiet as them, but around that, was it 20 megahertz you're working at?
Yes,
I don't think there would be. Yeah, I don't think there would be too much of that around here. So yeah, I must get your details, and we'll see if we can get a system going. Would actually like to get one going myself. So if I can get that going, I might suggest it to the society to lash out and buy a bit of gear to get online. We can also stream here mainly by the mobile networks. It's not perfect, but we can certainly get you some data.
Yeah,
sounds great. Thanks, guys.
I've got my SDR player ready to go already.
You sure do.
Okay, I must get some information on that. I assume it's all on the website, but as I say, I'm still pretty new at the moment. I'm still setting my dish up, and it is one of the questions I have to ask you guys about. Good SDRs to buy. I'm at that stage at the moment of lashing out to buy a bit of kit.
Well, if you're going to do Radio Jove, get the Radio Jove 2.0 system, and they'll send you all the stuff you need. So you don't have to make any. You don't have to guess, and they'll tell you how to put it together. So
sounds good. I actually did a 1.0, I suppose, and I bought a kit and soldered it all together with a little bit of success. I think I actually did get Jupiter, but I'd much rather get something off the shelf and plug it in.
Well, we're using the SDR Play RSP1A now, although several of the fellows are using different manufacturers, AirSpy and other ones. In fact, that's sort of been the problem, is trying to confine people to use one instrument, and so that you can have a little more confidence in the science and make sure it's not due to a different SDR. So, but they really have opened up a lot of possibilities with good spectral displays, and get to see a lot of interesting spectral features. Well, great, thank you.
all right. Let's see. Kevin and Kim and Grogu. If you don't notice it, it's the little guy in there.
Good afternoon, Southern Hemisphere types. We don't have a lot of news this month. I think it's mainly Supersid has been wiped and recreated from the ground up with code from Steve Burrell, and that has been working, and we're expanding on some of his Python codes to try to get the annotation working for us. Our Radio Jove 1.0 system, or 1.1, or whatever version it is, had a little a failure 2 days ago by some cables being chewed through. And we have rabbits. And the ground is still frozen, so it can't be repaired until spare parts come and the ground thaws out. Every other place on the cable lines for power and coax and audio were protected, except of course for the 1 meter section that was not protected, and that was the section that got chewed through. Other than that, we picked up an SDR, not an SDR Play, because that's a little out of our price range at the moment, but we hope to try to learn how to use it, doing some FM meteor detection, and then if that works out, maybe see how we can translate that over to a Radio Jove 2 system.
Great.
That's about it.
That should work.
We're hoping.
All right.
Kevin, tell us a little bit more about this Python and animation. Doing on what kind of data?
Steve Burrell's SuperSID code. We were using an older version from Eric Town that just dumped the data into a CSV data file, and then we did our own graphing and programming using Python and R and some GNU scripting. But we threw all that out with Steve Burrell's code. Apparently, one of his Python routines has NOAA annotation of solar events. that annotates onto our own data, but we haven't got that working yet.
And it would show animation over days or hours or what?
No, sorry, not animation, but annotation.
Ah, different word. Thank you very much. Okay, excellent. That sounds like fun.
Oh, sorry, it must be our accent.
All right. Let's see, Rob Lucas.
Yes, last month you asked me to give a status report on what I was doing. So what I did was, if you help me, I'll show you the presentation that I came up with, and we'll see how we go. So the first thing I'll do is I'd like to share my screen.
Go ahead.
It's supposed to come up, and anyway, the issue is, can you see this?
It's almost there.
Earlier, people were talking about eclipses. Well, I'm an I'm an eclipse chaser. And this is a map of some of the eclipses that I've been to.
Wow, goodness.
Wow.
Okay. For Exmouth, what I do is I study the sun's corona during total eclipses of iron 10 and iron 14 wavelengths. And I also have a high resolution spectrograph. So I take spectrums of the corona during total eclipses. Okay. But that's not what I really wanted to show everybody. But let's see if I can bring this presentation up. If I take the time to do it. Okay. So can you see this?
Yep, got it.
Let's see if I can make this work. So 25th of October last year, we hadn't been able to travel due to the pandemic. Okay, so what we did, our last trip was to Madurai, India for an annular solar eclipse. So on, when we went to Helsinki, we were supposed to meet up with our friends that we've traveled with for, for over 20 years, but they canceled at the last minute. Okay, so this is the radio telescope that's just outside of Helsinki, Finland. And the actual dish is inside this, I think geodesic dome. Okay, so I don't know what, the pictures didn't come up, but this is the base of the antenna, the radio telescope antenna that's inside that dome. Now, I don't know what's happened. Okay, but anyway, I use Open Office, and this is a picture of the dish itself. Okay, and it has this very interesting, technique for picking up the waves. Now let's see.
So do we see gaps like louvers there, or is that just struts on the back?
No, this was like louvers inside the dish itself, and that's the actual structure. And this is the rigid, the things that make the antenna rigid. Now I had a picture.
Okay, so we could have a screen, but you have louvers, and we're actually looking right through the louvers. Neat.
Yes. Now there was supposed to be an image of the array that they were using, and what this did, and I don't know what happened to. I have a picture of the actual eclipse itself, and that seems to have disappeared. And what was interesting was, because it was cloudy that day, the day that we went to see the partial solar eclipse, okay, what they did was they brought up on the screen what the dish was actually seeing, and you could actually see the sun's disk, and you could see the moon going in front of the disk for the partial solar eclipse, and I'm really disappointed that it doesn't want to work for me today.
Rob, can you go into presentation mode? Go into presentation and see if that brings it up.
The last time I've never done a Zoom meeting before. I've always done, face to face. So how do I do this presentation skills?
Slideshow up the top.
Slideshow.
Slideshow and no.
Oh, they're actually
pictures.
gone.
Yeah,
they're not in. They're not in your small. Yeah, they're not in your small version.
Wow.
Missing.
Learning experience.
Yeah, I think my experience with that is that sometimes you don't have enough memory and it shuts out some of your pictures.
Well, I tried to change that. I set up the memory, whatever.
Okay.
Have you got those pictures on your computer?
Yes.
Just
think I can-
open the picture itself outside. You know, don't, just raw.
The hardest part is to find these things.
Oh yeah, there you go.
There's that one.
Same picture, but I can't see any eclipse pictures in your files there.
There we go.
This was what they're, this was on a big screen inside the control room. And this is, you could see the moon actually going in front of the sun. Now, what this caused me to do was to figure out, I did some more research and I find out that the way they do this is they're using what they call a phased array. And I think the phased array is built on a printed circuit board, I thought that was way cool. Now I find that Analog Devices and Texas Instrument, have designed, integrated circuits so that you can actually control this phased array. And what the phased array does is it shifts the beam so that you can scan through, I think, 23, a little over 23 degrees of the sky, and capture these images. And I thought that was just way cool.
I want one of those. Instead of one pixel, now we got many. That's great.
I thought this was absolutely incredible. Okay, so the next thing is, let's see if I can find it. Oh, I hate this.
Not behaving.
No, what it means is, my last presentation was November, in India, and I haven't done anything since then. I don't know why it doesn't like me.
I think you're going to have to cancel in that box first. Yeah.
Let's just get out of this thing. So what I was trying to show, that's okay, we just give it up. The other thing I did was, I tried to join Sarah and I gave PayPal my details and it's still pending. I don't know why it hasn't been charged. So if anybody can, if anybody can have a look.
I know exactly what's going on with that. It doesn't work. It says pending. It never went through. I get to see along with the treasurer all the pending, all the stuff that went through. That happened on the Sarah conference. We just put up a new thing, and the PayPal has somehow broke with our store. So it never went through, and our expert Chip is working on getting it all fixed. But yeah, just we'll get you.
That's okay. Just a matter of time.
Yeah. Sorry about that.
So has he paid? Does he need to pay again? What's he do now?
Well, it doesn't. Well, we have to figure that out. There's a lot of people that tried to pay for the Western Conference and for memberships and for various other things through the store, and they think they went through because it said pending, but in fact, it never worked. PayPal never paid anything, and it never acknowledged the thing. But they didn't know that because it said pending. All right, so that's the worst of both evils. They think they paid, and we didn't get paid. So we don't know what's going on at the moment. As soon as we fix it, we'll have to come up with tell everybody. I think we got the list of people who tried, so we'll just contact them and do something.
Yeah, just send me an email or something, and I'll repay it, whatever it takes.
Yeah, sorry about that. We'll get it figured out.
That's okay. It's not an issue. I just thought maybe I did something wrong. The other thing is I've spent some time, and Tim, you came up with the EZRA, and what I did was I followed your video and I've installed, Easy RA on my system. Okay, and everything was okay until the last step. And for some reason, your instructions, and I must have misread them, but my earlier, installation of Python, crashed everything, and I had to start all over again. No, but I've made it work.
Oh, you made it work. Eventually, a success.
Yeah. But well, what you don't know is, I go back to the 60s, and I program in early C and 15 different languages. So when things don't work, I just go in and I figure it out and make it work.
I like your kind. Excellent. Thanks for the success.
Right. And that's
keep
okay.
going. Let it, post your successes.
Okay. Now I also had a picture of apparently this scope in a box. I bought the Wi-Fi antenna, and I've got the sawtooth filters and the low noise amplifiers, and I've got the whole system up. And I made it work several years ago, and I got a blip of the Milky Way when it went overhead in in the hydrogen. Okay, but I got that, and so now what's happened is it's sitting off to the side. And I've been out to the Waruna, the astronomy club dart site, and they have this it's a Fluor 5.9 meter disc sitting there. And what I've done is I took a look, and you guys have come up with this this antenna with the Kumar yoke, I think it is, type of thing, or choke. It's a choke, sorry. And I think, what I should do is, build one of those things and put it on this disc. And this disc was set up for, imaging, looking at hydrogen, years ago anyway. So, should be able to put that together. And I know that if you have something from, a radio, emitting, thing up in the sky, you need an optical telescope to take a look and see what it really is. Okay, and so next to that, I've got this 2.9 meter dome that I'm building, observatory, an optical observatory, and I've it's basically the base is ready to be finished off, and then we assemble the dome. Now, if I can find it, I was in Hobart recently, well, the last couple of years, and what they did for us was they took a look at Vela. And I have a recording of the Vela pulsar. Has anybody heard this before?
Go ahead and do it again.
Okay, I'll see if I can find it, but this it doesn't like me very much.
What's interesting, I've done we've got 23 pulsars, but we've never got an audio recording of a pulsar. We just get the sort of the digital signal, but we never made an audio recording. So I'd like to understand how you get an audio recording from a pulsar observation, and what do you have to do to make that happen?
Well, what they did at the antenna in Hobart, they pointed it at Vela, and what they did was they put the signal that they were receiving up on an oscilloscope, and then they took the output of that that's oscilloscope output and sent it to an analog to or a digital to analog converter, and and we've got the audio of it.
Oh, okay.
I would think we could cut it out of the data somehow, process it and push it.
It would be easy. It would be easy to do.
Well, for a bright one where you don't have to do a lot of folding. Problem is we do the folding, and yeah, you'd have to cut it out of the data, the folded data. So
sonifications become
you got to pull it out of the noise somehow.
Yeah, sonifications become fairly common or fairly popular these days. I've read a little bit about it. That there's things like the gravity wave detector. They call it a chirp. Well, that thing goes at incredibly low frequencies. So what you do is you actually do a translation of those low frequencies or high frequencies down to an audio frequency. and away it goes. And so they're using it for things like, as I say, the chirp. You can be watching forever on your screen. You might not see that, but you certainly hear it. If you're listening and you hear something go chirp, you go, that's something to look at. So the whole sonification thing is becoming quite popular, I believe. So yeah, I'm certainly interested in that too.
Was it my turn?
Yeah.
It's not playing the audio.
In the chat, okay, go out of share, and when you share again, there's on the bottom left, there's a an audio recording little square. You got to click that, and it'll transmit the audio of your screen to the Zoom.
It says a new share.
Yeah, unshare and then share.
Up the share.
Before you select the thing, there should be a little box on the left that allows you to do audio recording. Now, get out of this mode and unshare. Totally unshare.
How do we unshare this thing? Is it at the bottom or the top?
That's a good question. It should be on the top, I think, for you.
It's talking about a new share.
Yeah. Okay, just a minute.
Sorry.
Yeah, so what I did,
I'm stopping the share.
Okay, now share again, and before you
Share
select,
screen.
yeah, and now look at the bottom left, there's a shared system audio. But
Share sound.
yeah, that's it. And that, hopefully that gets it.
It's still quiet.
Well, can you hear it on your computer?
No, I can't hear it either.
Then it might be you. I mean, it might not be.
Of
You
course
should
it's
hear it on
me.
your computer. I mean, you should be able to hear it on your computer. If you want to email it to me, I can maybe play it on my computer to everybody. Would that work?
Let's try. I'll email it to you.
You got my email?
Sorry about this.
No problem. You got my email?
I'm sure I can figure it out.
Oh, here, I'll put it down.
I'll put it in the chats.
Yeah, that's where I'm going to put. Well, I see what you're doing.
We had some success with audio and meteors. They happen, and you can get a noise out of it, and then you can look away from the monitor and then see when they came by and capture the screen moments later. But you don't have to watch the dang screen all the whole time.
Yeah.
Sorry about this.
Oh no, this is 90% of what we do is figure out these technical glitches.
So
now, by the way, let's talk chat here. For everybody wants to chat, you need to save the chat before I go offline. Otherwise, the chat is lost. I'll get it in the recording section, but if you guys want to save the chat file, you should do it at the end when everybody's done.
I used to find 3 dots in the bottom right, but now I find 3 dots in the bottom left. So look around, click on that, and save chat. It ends up in like your documents / Zoom, right, in that directory.
All right. Okay, let me think what else we got. Okay, so while we're waiting on Rob's thing, and as soon as I get it, I'll see if I can get it online too. Let's see who else we got here. So Joe, I've got you next. If you got anything to show or tell us about your projects.
Yeah, good morning, everyone. I don't think I've actually been on live on any of these as yet, so I'll just introduce myself. I'm Joe, I'm from Melbourne, Australia, as well as along with Paul. Paul, I know from Zoom meetings, but I don't think I've ever met him in person. No,
Never met.
So I just got involved with the ASV in the last couple of years, and been slightly involved with the radio astronomy section. I just acquired myself a dish yesterday to see what I can do. I in the throes of building a telescope. I've got a little SDR. My main interest, I think, is in Python. I'm trying to learn Python. I'm a hardware engineer, been involved in radio initially, then medical for most of my life, with CTs and high-level X-ray equipment. But I've decided to try to do a bit in software, which I've always really liked, but never got myself involved in with much. So I'm looking forward to try to do some real science from the data that perhaps other people get or I can get. So that's hence the reason for the Python. But beyond that, not a great deal. Just to say, it's very good to meet you all. Ted, I've been following your EZRA. I've got it installed on the system here. Haven't done much with it yet because I don't have the hardware to connect up to it, but the hardware is probably 2/3 completed. But the hard third is yet to be done. That is the implementation of a dish or an antenna in the backyard. I'm also live probably in one of the most RF prone sections of Melbourne, and that is just at the bottom of Mount Dandenong, which contains just about every transmitter, every television, every piece of RF of infrastructure is just 2 or 3 kilometers away from me, about 2 or 3 couple of 100 meters above where I am. So that's it in a nutshell. Nothing to report, nothing to show at this stage, but just very pleased to meet everyone.
Sounds neat, Joe. You just made me realize that EZRA just doesn't have the same ring as the way we pronounce the Z. So sorry about that.
Oh, yes, I actually did catch on to that earlier myself, but I forgot about it. Yes, EZRA, yes.
Easy.
Oh, well.
Yeah.
All right. Okay, Rob and I are in communication. We're just got to transfer the file, and we'll get that. Helen, things going?
No, I'm here. I'm hoping this weekend to get the software downloaded to my scope in the box. And this has been real interesting. Some things I didn't know when we started out. So as you were discussing things, I've been Googling like mad because I had no idea what SuperSyd is, nor Radio Jove, but I sure know now. And also, I didn't know where the Vela Pulsar was or is. And I Googled that, and it said that its audio is a steady E-flat note. I found it interesting.
Well, it's also Southern Hemisphere, and
right.
We were able to get it. By the way, we were able to get it from Colorado, and we were at 38 degrees longitude, or excuse me, latitude. I think we were one of the highest guys to get, highest latitude guys to actually get it, and it was just barely over the horizon. We got it with our 60-foot dish. So, but it's the only pulsar I can say that Wolfgang couldn't get because he's too high. So that's the only thing we've got above Wolfgang. Otherwise, he's got 150 pulsars to go our 23. So, but I hold that badge of honor of getting Vela just because of our location. Anyway, let's see. Trying to figure out who else is on. Don Latham.
Oh, howdy. I'm just trying to eke out the tail end of the longest winter in our history here, I think. of about 30 years that I've been living here. As soon as I can get out around the snow, I'll get the antenna going, and then we'll see what we can do. Otherwise, not much. Been marshaling things, getting stuff together. I guess you can't see it, but behind me is a table full of stuff. So the next thing will be sorting stuff, and the next thing will be trying to get the antenna going.
What antenna?
Okay.
Oh, I have a 16-foot dish on a pedestal. I found some very nice 10th degree optical resolution. What do you call them? Anyway, and I need to get the drive system going so that I can at least pretend to have a 10th of a degree. I don't think it's going to work that well because there's a lot of slop in the system. It's got an old bull gear. My pedestal is came to me by way of essentially somewhere in the South Pacific with one of the old Tyros satellite helix antenna on it. It was made by Ant Lab in the good old days. So it's built like a brick outhouse, but it's not really geared for a 10th of a degree. So it's going to be a little difficult to try to get that out of it. I think maybe I can do it though.
All right. Rob, how you doing? Oh. You know, email me the file.
I'm looking for the file now.
You just had it.
Everything just stopped. I'm working on.
Perhaps we roll it up until next time, Rich.
Yeah, not a problem.
Okay,
so
we'll work on it.
I'm running out.
Advertisement. A little more advertisement for Sarah. We just did the Western Conference. I put the link to the YouTube channel for the Western Conference. Some of you guys who were talking about the nanograv and the using pulsars for gravity wave detection. Go to the keynote speaker. They're talking about the antenna, the array they're putting up will be able to do that. Also, the innovation they've made of getting a LNA that is very good for without being cryogenically cooled, and that has really, in fact, if you look at Wolfgang's too, that was the way he could detect the FRBs he's done, because he's got a LNAs up there that can be done on normal temperatures instead of being cryogenically cooled. Puts him in line with the big antennas that are cryogenically cooled. So look at those, Wolfgang's and that. And then, of course, the entire series of the CubeSat, STEMSat program, as well as our very interesting, my first cut at doing a Zoom walking tour with limited Wi-Fi. And so forgive me if I tried to cut out most of the dead zones, but it just sort of was fun to do. I'm not sure how fun it is to watch, but go ahead and try it. All right. Anybody got any last words? This has been really fun. Okay.
Very helpful. Thanks, Rich. Very good material for me.
All right. All fun.
Let's see if I've got it right. Good day, Al.
Not bad.
Okay, thank you. Good day, mate.
Good day. It's morning.
Good day.
Good day. Good day.
Yeah, we had this discussion about language differences, and